In the early 18th century, Georg Ernst Stahl was one of Europe's greatest writers on theories of chemistry and medicine, to the extent that he became physician to King Friedrich Wilhelm I of Prussia. However, he had disagreements with other well-known men of the time. For example, he disagreed on theories of medicine with Friedrich Hoffmann. Hoffmann was a colleague of Stahl at Halle, now in eastern Germany, and he had famously produced an 8-volume compendium on the properties and medical uses of substances. In addition, Stahl disagreed on theories of chemistry with Gottfried Leibniz, a German mathematician who hailed from nearby Leipzig and who had developed calculus independently of Newton. Stahl summarized the discussion in a book, Negotium Otiosum, which translates as idle business. Stahl's writings on chemistry contained both modern and ancient views. Thus, a modern definition of chemistry that he provided was counterbalanced by his belief that gold could be synthesized and his acceptance of the 4 peripatetic elements. Stahl also developed the now discredited theory of phlogiston, according to which a substance known as phlogiston is released every time something is burned. Thus, all flammable materials were deemed to be compounds containing phlogiston. Stahl's theory became widely believed over subsequent decades, and his fame increased, so that when Joseph Priestley discovered oxygen in 1774, he labelled it as dephlogisticated air. And Priestley's stubborn adherence to the theory led to him later being ridiculed as Dr. Phlogiston in a satirical cartoon. It has been suggested in some quarters that the theory of phlogiston may have been responsible for the lack of any major developments in chemistry, from the 1660s, when Robert Boyle published The Sceptical Chemist, to the 1760s, when hydrogen was discovered by Henry Cavendish. In reality, however, this is perhaps a bit harsh. Chemistry was never likely to undergo any major developments until hydrogen and oxygen, 2 of its most fundamental constituents, were discovered and their significance realized. And this was achieved shortly after their discoveries by French chemist Antoine Lavoisier. Once Lavoisier had realized that hydrogen and oxygen were elements, along with carbon, sulfur, phosphorus and the metals, the widespread acceptance of the peripatetic elements was soon forgotten, and a rapid development of modern chemistry was almost inevitably going to occur. And in fact, some reactions that Stahl had described, such as the conversion of metal oxides, then known as calxes, to metals by reduction with carbon, would prove useful to Lavoisier in his subsequent determinations of the general composition of the metal oxides and carbon dioxide. So perhaps it's best not to be too harsh on Stahl, who already in his lifetime had suffered the misfortune of outliving both of his wives and both of his children. Thank you so much for listening to the very end, and I hope to see you again sometime soon.